Greetings everyone, Dave Aschenbrenner here. I wanted to take the time to thank everyone for purchasing a stinger. You're helping making printing a better experience. Two things before we get started. I'd like you to check out those links and download the Marlin firmware. You can follow along with what those commands mean on there, and also you'll get the cheat sheet. We're going to start out by turning on your heaters, and we're going to reset your 0 position. And we'll do that with a M851 space Z0 command. And the M500 saves that command. If you look above in the script, you'll see the script keeps changing about every second or so. I have the verbose square checked, the little verbose box. We're giving it the G28. As you'll see in the picture, this is going on in real time. That is a command for your printer to home itself. The other commands, as you can see, that are sent up here is, I believe that's Marlin requesting a temperature reading. So if you have that sheet and follow along, you'll understand what these G codes mean. Makes it a little bit more clear now. A lot of guys out there have this already down. I don't want to talk down to you. This is for people trying to set their stinger up. So kind of bear with me on this. I've only been into this for a couple of years myself and not a real G code guy. We're going to use a piece of paper as a gauge, as you would. And we're giving it the G1Z0, and that is basically taking it down to the 0 where it touched off. Now if you look above up here, you'll see my pointer right underneath the stinger picture, and I hit that 1 millimeter up on the jog twice. So we're up 2 millimeters, which is above where the paper is gauging it. Now if you look down below, you'll see I'm going down 1/10 of a millimeter at a time. I keep doing that until I feel a little tug on the paper. You see my decreasing 1/10 of a millimeter. I'm at 120 and 1.2 and 1.1 millimeters. Now I have to really tug on that paper. It seems like it's a little tight. So when we set our distance or our offset in here, I'm going to give it a little extra. This is a way that you can make it, if it's a little tight, you can make it kind of gauge it. And this, I've done this quite a few times, so I'm doing this from experience. So I'm going to go about halfway in between. I'm going to do the M851 Z1.15. That's halfway between 1.1 and 1.2. Now you'll see me set it with M500. That sets it into the EEPROM's memory in the firmware. So now we should be all set, ready to go. We're turning on the temperature again. I let it get away from me. Should always do this with it at least 150 degrees extruder temperature and at least 50 degrees bed temperature. So we're just going to wait. I'm doing this in real time so you get a kind of a feel for how long it takes to do this. It's a pretty simple thing. You're tethering this to your computer. I have several machines and they're not near my computer, so it's kind of a hassle for me to take the machine into another room and tether it to that computer. Time to get a laptop. You can see that heater has a nice straight graph line. Another thing to mention while we're waiting here, I'm going to do another video, or I should have one in the can here soon, of the M303, which if you have your Marlin paper there, that is the PID calibration. So we're going to let this heat up, and what you'll want to see if your PID is calibrated, or your hot end actually, and thermistor and heater, if it's calibrated, you're going to see a straight line once it gets up to its set temperature up there. You can also see that on your verbose, on your EEPROM feedback, on your communication screen. We're doing this in simplified 3D, mainly because it's a slicing program, and it is also one of the best host programs you can buy. It's kind of got everything. A lot of people are using another program. Keep in mind these G codes and M codes for the Marlin firmware are the same for any one of your hosts or slicing programs. They'll all work the same. So they all understand that language. What you'll see next is a shot of the communications screen. You can monitor the temperature by either watching the graph or the temperature feedback that's coming from your thermistors and feeding back into Marlin. You'll see we're just about there, 199 out of 200, 56 and change, 57 out of 60. So we're just about ready to print. And when it gets that ready signal, you'll see the screen change. It gives it the command to home and go into its, I call it a tap dance routine, where it does the bed leveling. So we're going to start out. It first has to recognize where it is. It's doing the center probe. It dabs twice. And we'll go to 9 locations. We have it set for 9 locations. If you have a bigger bed on your machine, you can call out either when you're setting up your Marlin, you can set it up to do more locations. And you can set it up to do the distance from the edge of the bed. The way we have it set up, I believe 50 millimeters from the edge of each side. And we're going to pay attention to the screen, the bottom lines on the screen. After it's done its little hits on the screen, you see that Z colon 1.15. Now that tells you that what you put in there is the distance or the offset in here. So you can mark that down on a piece of paper, and if you ever lose your offset, you can reset it just by giving it that command, the Z command. I've done that before. I usually put a little piece of masking tape, or I take a felt tip marker and I'll put it right on the bed in the corner and take it off with acetone. You also want to probably want to mention this. You want to just check before it goes into its tap dance. Make sure there isn't a little plastic booger on the tip. Your tip is now actually sensing where it's going to be printing on the bed. Also, good to mention, make sure all of your wheels are tight, your machine is in tune. This is real important if you don't have a belt that keeps the motors from drifting between each other, the Z motors. You want to measure that beam across there. Make sure it's within a millimeter or 2 of the bed. There is a limit to how much that processor can hold, the difference in the heights of that. So irregardless of what your bed leveling system is, it will go out of range. So you want to make sure that that bar across there. I've got a couple really good videos. If you look through my videos, I've got some maintenance videos. I did one called Truing the X Beam, and that's real important. Make sure all your wheels are tight. I have one called Eccentric, explaining eccentric bushings. Make sure all your eccentric bushings on all your wheels are tight or within tolerance. Okay, now what's happening now is when we did the tap dance, we were at 150 degrees. That keeps the filament from melting out of the tip while it's doing its tap dance. Now you probably will see a little tail coming out of there as it warms up, depending on which. Now it's running off of what your program is. We actually have a program in here, and it's reading, I believe I've got 225 degree filament in here, so it's bringing it up to 225 degrees as it sits. and that's what it's doing right now. Everything else is ready to go. We're going to come over, do the wipe, and we're kind of done with the screen. We really don't care what's going on with the screen other than manually reading the temperature just to make sure that was right. I cut away from the screen. And we're doing a little, I call it a test coin. It's a 0.625 diameter, and it is, and it's 0.65 height. And the brim that it's doing right now, it's I believe my first layer is set for 2.21 millimeters on here, and we're just going to measure it. This is a good way to make sure that your offset is set correctly. You can also, if you're having elephant foot problems, you can also bring up the offset just a little bit on here. But this is a good way to test it. This will lay that perfect print down. One of the advantages of the inductive sensor is that you can really zero it in within a few microns of the surface. And the nice thing about the Stinger is that the sensor is away from the bed, so it's not affected by any temperature or temperature changes. Also, electricity from if you have a high voltage bed, that won't interfere with it either. You'll see the build surface I'm using here is actually just a piece of galvanized sheet metal that I purchased from a local sheet metal shop. If they cut it on one of these stomp shears, it will keep the sheet nice and flat from being warped. And they make a real nice surface. It has that zinc coated or zinc plated galvanized electroplated surface, and I find this to be a very good surface. I very seldom have to use any hairspray or adhesive on it, mainly because of the ability for this thing to lay that print down. If I've got some real fine supports, I'll just give it a little spritz of hairspray. If it's laying down a tiny little line or a short line, a little dot on the bed. You also notice there's no clips on there. I've got magnets underneath it. Okay, so we're going to do a measurement now. This is real important to see where you ended up with. Just pop under the edge of the razor blade. Let it cool off just for a second. I'll actually use my digital calipers here. We're looking for 2. We're looking for 0.2 on here. And there's a couple spots on here, one where it goes in and out, it's a little thicker, and right next to that where it's a little thinner when it starts. So there's where it went in and out, the 16. Everything else should be about a 0.2 on there. And that's about perfect. That's about as close as you can get it right there. That'll put down a perfect print. Now that's all relative to the way you've got your first layer set in your slicer. So mine's set at that. Yours may vary. Just check your slicer at your layer height. That does it, guys. Thanks for being part of this, and good luck with your Stinger. If you have any questions, I'm technical at 3dprinttoform.com.